Hey, I'm Richard, one of the developer advocates here at Chainlink Labs, and in this introduction into Web3, we will cover everything you need to get a basic understanding of how smart contracts work and actually get you to deploy two different smart contracts. So what are we going to need to do that? Well, first of all, if you're worried that you don't know something you need to know in order to get started with this, let me put aside your fears there. You don't need any pre-existing knowledge. If you can go to a website, click on buttons, and use your keyboard, that's all you need to get started. It's that simple. I will walk you through everything that you need to get going and understand the basics of Web3 and blockchain development. We're going to need a wallet. In this example, we're going to be using the MetaMask wallet. It's a fairly common wallet. There are others out there. There's nothing wrong with other ones. It's just this one's very common, and that's one we'll be using. We're going to need a web browser. I'll be using the Chrome browser. MetaMask should work with basically any web browser that's out there, so you'll be good to go there. And finally, we're going to use the documentation that Chainlink provides, walk through some contracts, and deploy those so that you can deploy your first smart contract. So let's get started. If you head to metamask.io, you should see a web page similar to this. We will be downloading the plugin for Chrome here and installing it in Chrome. Now, MetaMask, like I mentioned, is a wallet. What is a wallet exactly? Well, a wallet is a place that will enable you to hold your identity when it comes to blockchains and Web3. Your identity is very important. It's what holds the funds that are associated with your account, as well as gives you permissions to do different things. In this example, we will be using our wallet to secure some testnet funds. Now, a testnet is a network that mirrors the real blockchain, but it's a test network. So there's no real monetary value associated with it. What's really nice about that is we can deploy our contracts there and see how things work in an environment that is just like the production mainnet blockchain. In order to interact with that testnet, we will need to secure some funds or some testnet ETH, and I'll show you how to do that as well. So let's get started. We have MetaMask here set up. We'll agree to their terms and we'll create a new wallet. We can choose whether or not to improve MetaMask, and then we'll need to create a password. I will say one caveat. I'm going to do some things in this tutorial that you should not do. The first of those things is I'm going to create a password that's not very strong. You should create a strong password. You'll see here that MetaMask is even telling me, hey, your password is weak. So make sure you have a secure password. Next, we'll create our wallet. And when we create our wallet, we'll be presented with this option to either secure it or be reminded later. Securing our wallet means that we'll see our secret recovery phrase. This is going to be a set of words that are used to generate our private key. Now, secret recovery phrase, private key. As the names imply, those two things are things that you do not want to share with anybody else. You're going to see my secret recovery phrase. I'm never going to use this wallet again because of that. When it comes to these two things, it is very important to maintain the secrecy and privacy of those items. So we'll secure our wallet and we'll get our secret recovery phrase. Again, this is the things that you never want to show anybody. So we'll reveal our secret recovery phrase. You will need to write these down, keep track of them if you want to be able to recover this wallet. What does that mean? That means if something were to happen to this computer, my MetaMask wallet would be gone. I'd never be able to get it back. If I have this recovery phrase, I can regenerate my private key and get my wallet back. So this is an important piece of information. Make sure you store it somewhere safe. I'm just going to copy it and I'll use this here in a moment. Now, MetaMask is going to ask us to verify a few things to make sure that we have our words written down in the proper order and that we have the right words. When we click next, we'll see it's asking us for 3 different words from our phrase. So again, this will be to verify that you know the words in your phrase. Once we've typed them in, we can confirm, and that way MetaMask knows that we have our words written down. Our wallet is created, and MetaMask will take us to our wallet. And here we can see our wallet. We can see our account. We can see what network we're connected to. There's a few things that we need to set up before we get going. First of all, this account is set to connect to the Ethereum mainnet. That's what I like to think of as the production network. That's the real thing. This is where things actually have monetary value associated with them. We want to do all of our testing and deploying on a test network, specifically the Sepolia test network. There's been over time many different Ethereum test networks. Part of the reason why they come and go, unlike the Ethereum mainnet, is that there isn't any real store of value accumulated there. Testnets are essentially a copy of the mainnet in how they function. What's on them is different, but how they function is very similar. And we want to make sure that we're not thinking of them as a store of value. So we will go to these 3 dots here. We'll go to settings. In advanced, we will then turn on the show test networks option here. What this will do is it will allow us to change from the Ethereum mainnet here in the corner to one of the two test networks that we'd like to interact with. Again, in this example, we'll be using Sepolia. So we can change to Sepolia, and we can see that we have no Sepolia ETH. Uh, how do we get some ETH? What is ETH? So ETH is going to be the native token of the Ethereum network. And that native token is used in order to pay for transactions. It's how we pay our gas fees. Gas fees are the fees that are associated with making a change to the network. Uh, Basic way that a blockchain is set up is you have a bunch of different nodes within the blockchain, and they all have to agree on what is happening on the chain. And the way that you incentivize them to do this is by paying them a fee. So we will need to get some testnet ETH. Where can we go to get that? Well, the first place that we can go is to faucets.chain.link. So we'll need to connect our wallet. We click connect wallet, we'll accept the terms of service, we'll click MetaMask, and now we get this pop-up that shows up. It says, hey, do you want to connect MetaMask? It's going to have access to some things. Click next, it'll tell you what it's going to actually have access to. So it can see the address, account balance, activity, and suggest transactions to approve. We'll connect it, and at this point, we can request ETH and link from the Chainlink faucet. Now, there is this login via Twitter button. And part of this is because when it comes to testnet ETH, uh, faucets are places where you can get it. It gives you that for free. Given that it's for free, people will sometimes take advantage of that. So this is a measure to prevent people from taking advantage of this specific faucet. If you don't have Twitter, you don't want to share your Twitter information, another option down here is the Ethereum Sepolia faucet. If we go here, this faucet will actually allow you to do some proof of work. So your machine will need to run for a bit, and then you can claim your value there. But what will you need to provide? Here, you'll need to provide your Ethereum address. So we'll copy it from here. If we just click on this, it will copy it. You can paste it in here. Prove that you are not a robot by selecting which things are a motorcycle in this case. Click next, pick your motorcycle. Lots of motorcycles to pick. And then we'll start mining. I'm going to skip this part. You'll click start mining, and then from there, you can go ahead and wait for your computer to mine enough blocks. Once it's reached at least, I believe it's 0.05 ETH, you can claim those. So you click start mining, and you'll be good to go. I'll meet you back after you've got those. All right, so we're back here, and if we check MetaMask now, you should have some ETH as well. We've got some ETH, we've got a balance, we're good to go. So what do we do from here? If we head to docs.chain.link, getting started, look at deploying your first smart contract. This is essentially what we're going to be walking through in this tutorial. This is the text version if you'd like to kind of follow along there. We'll be doing a video version, obviously, because you're here watching me. So let's go through this. We've installed MetaMask already. The next thing to do is to write, compile, and deploy your first smart contract. We'll be using something called Remix. It's available at remix.ethereum.org. If you head there, you'll see something like this default workspace. And not to be too concerned about it, but just kind of walk through what we've got here. Remix by default can give you some contracts and scripts and tests. Don't worry about that. We're not going to be using that. We're just going to be using Remix in general. And what Remix is it's an online IDE or a development environment for Solidity. It lets you use Solidity right here in your web browser. Solidity is the language that we'll be using to deploy these smart contracts. So if we head back to the documentation, we can see our contract here. And you'll notice there's this button, Open in Remix. Well, that's going to let us open up this code in Remix. If we click that, it'll take us to a new instance of Remix. From there, we can see the code. So let's walk through this code and see what it does. The first thing is the first line is the license for this file. In this case, it's the MIT license. On line 3, we have the compiler version. That's going to be the version of the compiler. Solidity is a compiled language. That means that we write it out here in code that we can read. Then the compiler comes along and compiles it into code the computer understands, and that's the code that we use to deploy our contract. We have some comments on lines 5 through 8, and then we have our contract name. So on line 10, we're just saying, hey, this is our smart contract. We're calling this one Hello World. And within that contract, we have a few things. The first of which on line 11 here is a string. The strings are just normal characters, like a sentence is how I like to think of them, and it's public. That means anybody can access this string. They can read it. We have our constructor. The constructor is a special type of function that's run when this contract is deployed. That means when we actually submit it to the blockchain. So this constructor, it takes in a value, the initial message. And when this constructor runs, it sets message, that's that variable that we declared right above, to the initial message. So we deploy our contract with a value for that initial string. On line 17, we have a function called update message. And this function takes in a value that is new message. And essentially, if you look at line 18, you'll see that this function updates our message with whatever the new message is. Also on line 17, we can see it's public. That means, again, that anybody can access this. So this is our basic hello world contract. If you want to deploy this, how do you do that? There's a few things that we need to do first. On the left here, we have our compiler. And when we click on that, we should make sure that our compiler is set to the right version. It should pick this up automatically from line 3. And then we need to compile by clicking compile hello world. Now, my version here, I've already checked the auto compile option. If you haven't checked this, I really recommend it. Anytime you make a change over on the right, it's going to change and run the compiler for you. So we've got it compiled. Now we need to actually deploy it. This option here is deploy and run transactions. This will actually let us interact with the blockchain. So we've got our wallet set up. We've got funds for our wallet set up. Now we're going to actually deploy a contract. It's pretty quick, right? It hasn't been that long. You've already accomplished a lot. Let's get this deployed. You're going to want to note the environment that you're deploying to. Remix has several VMs that you can choose from. VMs are virtual machines. They're essentially a clone or a copy of the actual Ethereum blockchain, but they run locally. Now, we want injected provider MetaMask, and it's going to ask you if you want to connect MetaMask to this website as well. What we're doing now is we're taking MetaMask and we're injecting it into the website so that we can actually use our wallet, our private account, to deploy a contract to the blockchain. Once we've got that connected, now we can click deploy. But before we do, let's go ahead and set our initial message. We'll say hello world, and we'll click deploy. This will ask you to confirm this. Now, this brings up something that's interesting to note. In Remix, the general rule that they follow is when you see an orange button, it's going to require for you to approve a transaction because it's going to cost gas. It's actually making a state change to the blockchain. You're actually doing something on the blockchain. The blue buttons, like that one at address, those are going to be view functions. They're going to be reading from the blockchain, but you're not actually changing the state of the blockchain. So it's kind of just something to keep in mind. Click confirm. And now we're going to be watching this little window right here for our transaction to be confirmed. We're looking for that green check mark. Speaking of green check marks, one thing to mention as well is when it comes to the compiler, if you were to do something in here that was a mistake, like this is a goof, I made a mistake, I goofed up, and I compile, you'll notice you get this red here. That's going to tell you that something is wrong. So we'll get rid of that and we'll compile again and we'll see our green check mark. If you're not seeing green check marks, you're seeing something else, maybe something's going on and you need to check out what's happening. But we've got our green check mark here for our deployed contract. We head back to our deploy tab and we scroll down a little bit, we'll see hello world in our deployed contracts down here. If we open this up, these are those functions within our smart contract. So we have the update message function, right? That's the one here that will actually change the message. And then we have this message call. What that will do is it'll read the value of message. So if we click that, we can see the message is currently hello world. So at this point, I want you to take a step back and just realize if you've never interacted with Web3 before, you have successfully deployed a smart contract on a blockchain. If this is the first time you've done that, congratulations. Give yourself a pat on the back. That's huge. We've got our message there. Now we're going to interact with the blockchain. So we're going to update the message to something a little more friendly. Say, howdy, world. And we'll click update message. Again, we'll need to confirm it because we're making a change to the blockchain. We'll wait for this transaction to be confirmed. And just like that, we've got our transaction confirmed and we're good to go. Now we can go ahead and check our message again. Currently it says hello world. If we click on message to see what the current version is, it says howdy world. And one thing to note too, here when we have these transactions, you can see it here in this log. You can also see it if you went to MetaMask. You can see your transactions, right? Now, if we look at update message and we click on this, it'll tell us all the information about it. But if we click view on block explorer, this is something that's pretty neat. So this is Etherscan. Etherscan kind of lets us see all the information inside of what's going on the blockchain. Every single transaction, Etherscan will let you see it. And here we can see that this is the actual call from our wallet. You can see here's 3C81. If you look at my wallet address, It's 3C8. We don't have the one there because it cuts it off, but that's me. This is the transaction, and this is the contract that I'm calling to. So it's recorded on there. You can see how much it costs and everything like that. That's pretty cool too. This just goes to show the transparency and power of blockchain when it comes to ensuring everyone can see what has happened and everyone knows. That transparency piece is one of the benefits of using a blockchain. All right, so we've got our contract deployed, we've interacted with it. Fantastic. What if we want to do something a little bit more interesting? Well, if we head back to the documentation, and instead of deploying your first smart contract, we look at consuming data feeds. Now, what exactly are data feeds? So before we dive into what data feeds are, let's talk a little bit about what Chainlink is. When we were talking about the blockchain, we mentioned a bunch of different nodes, right? A bunch of different computers that all need to come to agreement. That's why blockchains work. When we have an environment like that where everybody needs to come to agreement, they need to reach something called consensus. And consensus is easy to reach when we ask a deterministic question, right? I like to use the example of what's 1 plus 1? Now, this is pre-recorded, right? I'm in the past and I'm asking the question, what's 1 plus 1? My answer to that is going to be 1 plus 1 is 2, right? If you were to answer the question right now, hopefully you are going to agree that 2 is the answer. It's not a trick question, it's a very easy question. And that's a deterministic question and a deterministic answer. It doesn't matter where or when you ask that question, it's always going to be 2. Now, if I were to ask you a little bit different question, like what time is it? Or what's the temperature? It depends, right? It depends on when you're watching this. It depends on where you are when you're watching this. Any of those it depends questions, those are non-deterministic questions, and blockchains have a hard time reaching consensus. Because just like you and I probably aren't going to agree on what time it is or what the temperature is, different nodes in a blockchain network aren't going to be able to agree when they answer those questions as well. In this example, we're asking the question, what's the price of Bitcoin in terms of USD or dollars? It depends, right? It depends on when you ask it. It depends on what source of information you're using to answer that question. That's a non-deterministic question as well. Now, how do we get around that? This is called the Oracle problem. It's bringing real-world data onto the blockchain. And that's what Chainlink solves. Chainlink is a distributed Oracle network. Basically, it's a bunch of different Oracle nodes or computers that can answer questions for you. And in this case, we're going to bring that data of Bitcoin price on-chain into our smart contract. And we'll see how easy it is to do that. But to answer the question of how do we do that, if you are to take a value like the cost of Bitcoin, and you get a bunch of different answers back for it, you can then take that answer set and ask a question that becomes deterministic, like what's the median value of this answer set? Answering the question, what's the price, is hard. But answering the question, what's the median value of all the answers to that question, then becomes deterministic. So let's see how we can actually do that in a smart contract. And don't worry, like median values, deterministic, non-deterministic, that went over your head. You aren't going to need it in order to continue on with this tutorial. So we have here our example contract, and we can again just click on the open and remix button, and let's walk through what this actual contract does. So again, we have our license, we have our compiler version. Line 4 is something new. We have an import statement. What import does is it brings something from another contract into this contract. In this case, it's going to be an aggregator v3 interface. It sounds complicated. Essentially, it's aggregating or getting the information together from the different oracles for that price feed information that we'll see in just a moment. We have some comments here, and then we have our contract starting on line 22. This contract is called data consumer v3. We can see that we set up a variable called data feed that is of the type aggregator v3 interface, and it's internal. That means that it's not accessible to everyone. In the other example, we had public values. Those are accessible to everyone, right? Anyone could see that. Internal means only within this contract can we see this value. We have some more notes about the network, Sepolia. Remember, that's a test network that we're on. We have the aggregator, it's Bitcoin in terms of USD. And then we have the address. Now, the address is going to be the address for that aggregator. Each different price asset pair that we have value for like this is going to have a different address. We set up our constructor. That's the thing that's run at the beginning when we actually deploy our contract. Our constructor is going to be set to the address that we mentioned above in the comments. And that's it, right? We set up our data feed when we deploy this contract. The only other thing we have in this contract is a function called get latest data. And it's going to return the latest answer or the latest answer to the question Bitcoin in terms of USD. And you can see it's a public view. Public means anyone can see it and run it. View means that it's not making a change to the blockchain. Views are things that we just read from the blockchain. It's going to return an integer value. And then we have lines 42 through 46. Now, these look a little weird. And what's going on here is we have a bunch of different values that are returned on line 47. So data feed.latest round data. That's going to return a bunch of information to us. And it returns things like the round ID, the answer, the value that we're looking for, the started at time, the timestamp, and then the answered in round. Since we don't care about those other values, they're commented out. If we were to leave them in there, we get a warning saying, hey, you have variables that you're not using. So we kind of leave them in there with a comment just so we can know what's being returned, but we're not actually using it currently. All right, so we've got this file here and we need to compile it, right? So we go to our compiler. If you have auto compile turned on, you probably already have a green check mark over here. If you don't, click compile. I'll go ahead and turn auto compile on just so it's on for the rest of things. And we've got our green check mark. That means we're good to go. We'll head to the deploy. And again, we'll change to the injected provider at a mask. We'll make sure that we're deploying our data consumer v3 and we'll click deploy. Again, we'll need to confirm this and we'll wait for our confirmation down here and our deployed contract to show up here. Now again, this is going to read from data that's already on the blockchain. And then we'll be able to see the answer to the question of what's the price of Bitcoin in terms of USD. We'll expand this and we have our one function here, get latest price. And it's blue. Remember, that's because it's a view. We're not actually changing anything on the blockchain. So we'll click get latest price and we get this really large number back. Now, this is the price of Bitcoin according to the Oracle network. It seems really large, right? One interesting little fact about Solidity is it doesn't have the concept of decimal places. So it's whole numbers only. This whole number has been inflated by 10 to the 8th power in order to provide us with more accuracy. So really what this value is 1, 2, 3, 4, 5, 6, 7, 8. We'll add a decimal place right in here. So this is a more accurate representation of what the actual value is from that data that we're getting back on chain, asking what's the price of Bitcoin in terms of USD. So that's it. You've done it. Like, hopefully this was easy. I think it's pretty approachable. We've gone and created a wallet using MetaMask. We've funded that wallet with some testnet ETH. We've gone and used a smart contract to create a hello world smart contract. Every programmer's first contract, right? Like hello world. We've gone ahead and used Chainlink price feeds to get data from off-chain into our smart contract. Hopefully you enjoyed this. From here, where do you go next? Basically, this is what you need to get started with Web3 development. You understand like the very basic foundation of what's going on. If you were to head back to the documentation and go to the top, you can go to docs.chain.link. You can look at the other products that Chainlink offers. The documentation here is fairly approachable. It's maybe not quite as user-friendly as this video was, but it's a great place to start. And yeah, hopefully this has encouraged you to learn more from here and start building stuff. Thanks for watching this, and I can't wait to see what you build.